Welcome everyone. We are going to discuss about base level and its significance. What is a base level? A base level is defined as a surface of equilibrium between erosion and deposition. That means it is an imaginary and dynamic surface above which there is a zone of erosion and below which there is a zone of deposition. Now, by a zone of erosion, I mean that it is a zone where erosional mechanisms predominate over the depositional mechanisms. And by a zone of deposition, I mean that the depositional mechanisms dominate over the erosional mechanisms. It doesn't ever mean that only erosion and only deposition can take place in these regions. Now, some authors and some texts have considered the mean sea level to be coinciding with the term base level, but actually it is not so. Base level lies somewhat below the mean sea level, and if we produce the base level from the oceanic part to the continental part, we will get the lowest level of continental denudation. That is, in the continent above this line, or above the lowest level of continental denudation, we get a zone of erosion, and below the lowest level of continental denudation we get a zone of deposition. Now, what are the factors controlling base level? The first and primitive factor is eustasy. Eustasy is actually defined as the height of the sea surface. Now, the height of the sea surface from where? Today, if someone asks me what's your height, I say it's 1.8 meter from the ground which I am standing. So, what is the height of the sea surface from where? Actually, eustasy is the height of the sea surface from the center of the earth. Now, the height of the sea surface can also be measured by some other terms as shown in this diagram, and one of them is the relative sea level. Relative sea level is the height of the sea surface from a datum plane, and the datum plane that we have considered here is the base of the oceanic crust. And over this oceanic crust there is a thick pile of sediments, and this thick pile of sediments is known as accommodation space, and from the relative sea level, if we subtract this accommodation space, we get the water depth of that region. Now, again, coming back to our term eustasy. Eustasy is denoted as capital E, and it has been designated that there are two types of eustasy. One is tectonoeustasy and one is glacioeustasy. Tectonoeustasy or tectonoeustatic changes are very major changes and rapid changes. They are actually controlled by addition or subtraction of crustal materials. Say, for example, during the time of the mid-oceanic ridge formation, water equivalent to the volume of that of the mid-oceanic ridge shifts to the continental portion. Thus, we see that there is a sea level rise. On the other hand, if there are cases of crustal subtraction or subduction of crust, we see that there is a sea level fall. Glacioeutatic changes are very slow, and they are rather controlled by climatic factors. Now, during the ice age times, when the entire continent was covered with glaciers, who actually contributed to this glaciers? It's the seawater. So there was a huge level of fall in the sea surface. And now, when we are suffering the warm ages, we say that within the next 100 years the sea level would rise by 100 meters. Now, why? Because the glaciers are melting and this molten water is contributing to the sea, thus rising the sea level. But these are slow changes. Glacioeutatic changes are much slower compared to that of the tectonoeustatic changes. So, another factor that controls the base level is subsidence or uplift of the datum plane. Now, the datum plane, as mentioned earlier, it is the base of the oceanic crust, and if I keep the eustatic sea surface as constant, and if there is a subsidence in the oceanic crust, then there will be a rise in the base level, and keeping again the eustatic surface constant, if there is a crustal uplift, there will be a fall in the base level. So we see that the subsidence also becomes a factor controlling the base level changes. Another is the rate of sedimentation, or the rate at which this thick sediment layer or the accommodation space forms, that also regulates the base level changes. So if the base level is denoted as B, eustatic rise is plus E, eustatic fall is minus E, crustal subsidence is plus S, crustal uplift is minus S, rate of sedimentation is R, then the base level B is denoted as plus minus E plus minus S minus R, based on whether there is eustatic rise or fall or subsidence or uplift of the oceanic crust. In this following set of figures, the rise in sea level has been discussed. The rate of sedimentation has not been considered in these figures because the effect of the rate of sedimentation is considered quite negligible with respect to the subtotal effect of subsidence and eustatic rise. So we see that there is a relative rise in sea level when there is a crustal subsidence and when there is a eustatic rise. So that's a very common phenomenon. There can also be a relative rise in the sea level when there is a subsidence and an eustatic fall, but the rate of crustal subsidence is greater than that of the eustatic fall. There can be an also relative rise in sea level when there is a eustatic rise and there is no subsidence, or there is a subsidence but there is no eustatic changes. There can also be a case of relative rise when there is a eustatic rise and a crustal uplift, but the rate of eustatic rise is greater than that of the crustal uplift. So the following figures here show cases in the fall of sea level. The first one is a very generalized case when there is a crustal uplift and a eustatic fall, then there is a relative fall in the sea level. But there are some other cases also. Say for example, when there is a crustal uplift with an eustatic rise, but the rate of crustal uplift is much greater than that of the eustatic rise. So then also there is a relative fall in the sea level. There can also be relative falls in sea level when there is an eustatic fall with no subsidence, or there is a crustal uplift with no eustatic changes. Relative fall can also occur when there is an eustatic fall and a subsidence, but the eustatic fall dominates over the subsidence. Now, from our earlier discussions, we have found that there are events of base level rise, there are events of base level fall, and accordingly some events have been designated. And the first one of them is transgression. Transgression is defined as the rise in base level, and it results in a retrogradational stacking pattern. Retrogradational stacking pattern, in very simple terms, means a fining upward sequence. That means amount of silt portion increases with respect to the sand portion as we move upward in a sequence. It occurs when the eustasy and subsidence both are very positive with insignificant rates of sedimentation. In the figure that I have shown here, you can see the topmost layer, the dark colored sediments represent silt, and the silt proportion is very high here. So we can say that the topmost layer is representative of marine transgression. So the next event is regression. Regression is generally the fall in base level, and it is represented by progradational stacking pattern. Progradational stacking pattern, in very simple terms, it means a coarsening upward sequence. That means the sand is to silt ratio increases as we move upward in a sequence. Generally there are two types of regression. One is a forced regression, one is a normal regression. When there is a rapid eustatic fall combined with a rapid crustal uplift, then there is also a drastic base level fall as a resultant of these two. This event is known as a forced regression. But somehow say that the eustatic level is also rising but not so rapid, and the crust is also subsiding. But the rate of sedimentation is so high that it dominates over the total effect of eustasy and subsidence. Then also we see that there is a base level fall. This type of event is known as a normal regression. And in this figure, if you see the middle layer, you will find that the sand portion is much more greater than that of the dark colored silt portion. So that represents regression. So always when you see a sea level rising, it need not be a transgression or a transgressive event. If we can understand what are the base level changes, then only we can designate them as transgression or regression. We have already seen that there is a sea level rise but a base level fall, so that was designated as a event of normal regression. So what modern authors do is, when they see a rise or fall in sea level, in spite of designating them as transgression and regression, they designate them as relative sea level rise or relative sea level fall. So you can refer to these few texts for further references and further studies. I hope you would like it, and thank you very much for your patient hearing.